One of the tools that we have in our toolkit for physics is this free body diagram. And it's a way to quickly and easily show all of the forces that we care about in a given situation. So let's jump right into it. We know that multiple forces can act on a single object. And this should, this is intuitively makes sense. That is the worst way of writing single because it is incorrect. Can act on a single object. And we know this, like I said, intuitively, you know that you can have a tug of war, two people pulling on the same rope. That's two forces acting on the rope, one person pulling, the other person pulling. Free body diagrams are just a simple sketch of all of those forces. It's a way to say, here's all the forces acting on this specific object. So now to draw one, what you want to do first is draw a small dot to represent the object. So it's not a circle, it's not a square, it's not a box, it's just a small dot that's as small as you can make it. Then you're going to draw each force as an arrow. So each force is going to be an arrow that's in the diagram. Each force should start on the dot and point away from it. So even if something is being pushed, like if I'm pushing from the right side here, you don't draw it like this. Instead, you would draw on the other side like this. Arrow length should match the magnitude of the force. So if you've got one that is bigger than another, it should be drawn bigger than the first arrow. They don't have to be precise, but they should be roughly equivalent. And all arrows should be labeled with the force. So if it's a frictional force, you should have a label that says force friction. That's what we're going to do for a free body diagram. I'll show you an example here on this next slide. A child is sitting on a swing at the park. The parent pushes them with a force of 20 newtons. The other two forces acting on the child are the gravitational pull downwards and the swing seat pushing them upwards. And you see that we've got all the values in here. Draw a free body diagram representing the situation. So first we're going to draw a small dot to represent the child. It says they're pushing them, the parent is pushing them with a force of 20 newtons. So they're getting a sideways push from the parent, and this will be FP equals 20 newtons. Then they've got an upward and downward force, and these you can see are roughly equivalent. They're much bigger than the 20 Newton push, and this is the force normal of 200 newtons, and this is the force, the gravitational force of 200 newtons. And so this is an example of free body diagram. Again, draw the dot, draw all the arrows going outwards from the dot, label all the arrows, make sure there's everything for all the forces. If you have any questions, as always, please let me know.